I'm Anil Kumar. Welcome to my series on related and correlated angles. In this video, we will learn some concepts and express the given function as related acute angle. We'll also express them as correlated acute angles, and then we are going to evaluate the trigonometric expressions. So I have 8 examples here. The numbering is a bit wrong here anyway. So we'll talk about what are related acute angle and what are correlated angles. Then I'll take some of these examples. Let's consider a related acute angle first. When we say related acute angle, in that case we are trying to express any trigonometric ratio with reference to a congruent triangle in quadrant 1. So normally we can consider this to be a triangle in quadrant 1 where let's say that the angle is let's say angle is theta. Now if this angle theta is greater than 0 degrees, let me say greater than equal to, but less than equal to 90 degrees, we call this as an acute angle. Perfect. So we have to express everything in terms of angle which is between 0 to 90 degrees. Those of you who are working in radians, for them to be between 0 to pi by 2 radians, right? Now that is the basic concept. Now we are using two terms. One is related acute angle, as we are saying. Let me underline this. The other one is correlated. Now when we talk about correlated angles, then we consider a triangle kind of like this, where if I have angle, let us say x here, and this is 90 degrees. In that case, what is this angle? Well, clearly this angle is 90 minus x. So this is 90 degrees minus x. As you can see here, in any particular triangle, if we have sides as A, B and C, in that case cos of x will be equal to, let's say, B over C, right? Now in that case, B over C could also be written as sine of 90 minus x. Is that correct? So we are writing cos in terms of sine, and that is what it really refers to when we say correlated. So whenever you're talking about correlated, think about it, right triangle. You can express every angle as its counterpart. For example, what is sine? Let me write now x here. Sine x will be A over C, right? I could write this as cos of, instead of 90, let me write pi by 2 this time. Pi by 2 minus x. So when you write in this form, it becomes correlated. Sine in terms of cos. And similarly, we could write tan, let's say pi by 2 minus x, as correlation with tan is cotangent, cot of x. So in a particular triangle, we are focusing in quadrant 1 since all the angles are acute angles. So we are in quadrant 1. Everything is positive, right? So that is how they are related. Now let's get back to examples where we'll take up obtuse angles, or some may say reflex angles. So if that is the case, then how do we express the trigonometric expressions in terms of their related acute angles and correlated acute angles? That is the exercise we'll do. Once we have expressed them as related and correlated acute angles, then we will evaluate. Now to evaluate, I'm going to use special triangles, only two of them. One is, as you know, 30, 60, 90, or let's say this is 60 degrees. In that case, the sides are 1, 2, square root 3. Right, so this is 30 degrees. You could also call this triangle as 60 is pi by 3, that is pi by 6, and pi by 2, right? So that type of triangles, or let's say pi by 4, which is also 45 degrees, those who are doing in radians, the sides could be 1, 1 square root 2, right? So these are the triangles which we'll use to evaluate. Perfect. Now let's take up concrete examples and understand. Now let us take the examples. We'll understand again what is related acute angle and then evaluate the given expressions. So as I was saying, when we talk about related acute angle, we are looking for an angle, let's say theta, which is between 0 degrees to 90 degrees, or you can say theta is between 0 to pi by 2 radians, right? Sine 240. Let us try to sketch this, right? So we'll sketch it here. Once we sketch, we'll write it in terms of the related acute angle and then evaluate. Sine 240 really means that we're looking for an angle which is 180 plus 60, right? So that becomes sine 240. Here, the angle is, you could write this as sine of 180 degrees plus 60 degrees. That really means you are in quadrant 3. The acute angle is 60 degrees. And sine is negative here. So we could write this as negative sine of 60 degrees. To get the value, what we do is that we just sketch our special triangle. The sides are in the ratio of 1, 2 and square root 3. Sine 60 degrees, that is 60 degrees. Sine is square root 3 over 2. So we could write this as negative square root 3 over 2. Is that clear? So what we have got here is a related acute angle. Written this expression in terms of related acute angle, and then what we did was we evaluated. So that is to find the value, which is this line, right? So we are going to do the same operation for the next three. So let's try to understand cos minus 7 pi by 6. So when I say minus 7 pi by 6, it means we are moving clockwise, that is negative angle, pi by 6, 7 pi by 6. So this is 6 pi by 6, right? And then we go one more, so we get 7 pi by 6. So this is 7 pi by 6 negative, since we are moving in that direction. As you can see, we are in quadrant 2. In quadrant 2, cos is negative, right? So that's the rule, you know. All are positive here in quadrant 1, sine in 2, tan in 3, cosine in 4. So negative for being in quadrant 2 for cosine, and the angle which it makes is pi by 6. So we could write this as cos pi by 6. So this is in terms of related acute angle, correct? I did not write pi plus pi by 6 this time. Okay. Okay. Let's calculate the value. Of course, it is negative pi by 6. That part is always positive. Acute angle 90 degrees, right? Within 90 degrees. Pi by 6 is this angle, right? Pi by 6. So cos is square root 3 over 2. So let me write down square root 3 over 2 as our answer. Is that clear? Now let's take up the next one, which is cotangent 33 pi by 4. Now that really means you go 8. This is 8 pi by 4. Is it okay? So you got 4 rounds. and then you land up here in quadrant 1. So this could be written as, we could say 32 pi, that means 4 rounds, plus another pi over 4. Is it okay? So that gives you 33 pi by 4. Is it okay? So let me write like this first. So that's absolutely clear. Quadrant 1 is positive, cotangent pi by 4. And now we'll use another special triangle, which is for pi by 4. Normally we write 1 square root 2, but you could also use the values multiplying by square root 2, 2 square root 2 square root 2. Is it okay? So for cos pi by 4, which is that angle, we get a value which is square root 2 over 2. Next one is sine 13 pi by 4. That is to say, let me redraw this here. 13 pi by 4 means that positive. So 1 full round, that is 8 plus 4, 12. And now you come to this quadrant, pi by 4. So that's the value. So this is 13 pi by 4 for you, right? So you could say you are in quadrant 3. Sine is negative, and the acute angle is pi by 4. So these two things are very critical, and the value is square root 2 over 2 with a negative sign since you are in quadrant 3. So I hope all these steps are absolutely clear. Is that okay? That is how you should be doing. Let's move on and take up the other set. Now we'll talk about express each as correlated acute angles. So now correlated. Correlated really means we are looking at this triangle, and well, let's say this is a 90 degrees triangle. If this angle, let me write x here, in that case that angle will be pi by 2 minus x, right? So sine becomes cos, cos becomes sine. So if this is A, B and C, they are correlated. That is to say, cos x could be written as sine of 90 degrees minus x. That is what it is. Sine x could be written as cos of pi by 2 minus x. So that is in degrees, this is in radians. So that is correlated. So let's try to figure out the angles with respect to correlated. That means we have to write tan in terms of cotangent. Remember this. We have to write this in terms of cot. We have to write tan as cot. Cot of what? We have to write secant as cosecant, and we have to write cosecant as secant. Those becomes correlated. You are looking from the opposite side of a right triangle. Is it okay? Now, 120 degrees means you are here. So the acute angle is 180 minus 60. So the acute angle here is 60 degrees. If 60 degrees is your angle here, what is 90 minus 60? So that cot value is 90 minus 60 degrees. That is how you get. So we have related tan with its correlated angle, that means 90 minus this. Tan changes to cot. You will see you are in quadrant 2, and therefore we are writing this as negative. You got the idea, right? Negative. So that becomes the value. This is correlated angle, correct? Well, let me write this as related angle also. This is correlated. So this column is correlated. This time let me write related angle. That is, I could also write this as minus tan of 60 degrees. This is related. Tan in terms of tan, as we did in the previous examples. Now let's evaluate 60 degrees. Let's get back to our special triangle, 30, 60, 90, which is 1 to square root 3. That is 60 degrees. Tan is square root 3. So we get the answer as square root 3 for this particular thing. Is that clear? Right? Okay. I think the related angle is better known to you. So we'll first do the related angle. Tan minus 8 pi by 3. 8 pi by 3 minus means you're going in this direction. This is 6 pi by 3 when you go one full circle. So 8 means one more and one more. So you are here, 8 pi by 3 minus 8 pi by 3. You are in quadrant 3 where tan is positive and the acute angle is pi by 3. So we get tan pi by 3 as our result. For correlated angles, we want to write this in terms of cot. Cot is correlated with tan. So in a triangle, pi minus pi by 3, right? So we'll write this as pi minus pi by 3, which you know is, pi by 2 minus pi by 3, right? Which is how much? You could take common denominator 6, right? So we could say this is cot of 6, 3 pi minus 2 pi, which is same as cot of pi by 6. Is it okay? So if you have pi by 3 here, that one is pi by 6 or 30 degrees. Is that okay? So I'm just mixing them up. So that is the correlated angle. So in this particular triangle, if you look at cot, you again get the same value, which is, we're looking at pi by 6, right? Cot. So square root 3 over 1. If you look at from tan pi by 3, this is pi by 3, square root 3 over 1. So either way, you get your answer as square root 3. Does it make sense to you? So I hope the concept is getting clear, but it's kind of confusing, correlated. I agree with you. However, that is how we could learn, right? So secant, let's do the similar way. Let's find the acute angle first. Let me sketch a new one here. Okay. Minus 5 pi by 3. So this pi has been divided like this. This is 3 pi by 3, 6, 1 less. So that is minus 5 pi by 3. You are in quadrant 1. So it has to be positive. Is it okay? So it is positive. And the acute angle is the 6th pi by 3, which is secant pi by 3. Correct? So for the acute angle, look at the triangle. You already have pi by 3. Pi minus pi by 3 will be pi by 2 minus pi by 3 will be pi by 6. So I could write this as pi by 6. Does it make sense? That is how you can easily get correlated angle. Now, let's evaluate secant pi by 3, reciprocal of cos, of course. So it is, if you're looking from this angle, 2 over 1. So it is equals to 2. Perfect. Positive since you are in quadrant 1. Next one, cosecant minus 11 pi by 6. So 11 pi by 6, this is again 12 pi by 6. I should write minus here when we go like this. So it is 1 less, so kind of like this. Acute angle being, so I'm writing acute angle first, cosecant pi by 6. Now I'm writing the correlated angle with secant, which will be pi by 3. Is that okay? So sometimes it may be easier to work it like this, right? So pi by 3, you can see, from that side, this is pi by 3, right? Secant is adjacent 2 over adjacent side, so it is equals to 2. So that is how you get your result. Perfect. You see it makes sense. You see how it is equal, right? So you get the same result. So I'm highlighting you how we get the same result and how they are related. So these two are actually also related. So as you can see, these are also related. Perfect. So sometimes if we do not include acute angle in between, and if you only write correlated, let me tell you that, caution. Caution. Since we have acute angle, we have used these angles. But if it was only correlated, then there's an alternate way. You can add and subtract 360 degrees to get correlated angle. That really means how do you come back to the same position? Is that okay? So you could do that, or you could do plus minus 2n pi, since these are circular functions, right? This is for sine and cosine, secant, cosecant also, but for tan, you could do plus minus 180 degrees. Anyway, I hope this helps you to understand how we could write any trigonometric expression in terms of its correlated and related acute angles, and then evaluate. Feel free to write your comment, share your views, and if you like and subscribe my videos, that'd be great. Thanks for watching and all the best.